Foraging for food is an essential and major part of an animal's life. Just to survive, an animal needs to meet an energy balance, which is the amount of energy from their food source compared to the amount of energy used for foraging or hunting. If they want to grow or increase their fat storages, they need to upset this balance by either eating more food or using less energy. Displacing this balance is especially important in migratory marine mammals that spend extensive periods of time and distance diving just to find their food, and this can be achieved by their state of buoyancy. Neutral buoyancy is an animal's average body density is equal to the density of the liquid it is immersed in, and it will neither sink nor float. A 2014 study called The Foraging Benefits of Being Fat in a Highly Migratory Marine Mammal aimed to determine the foraging benefits of highly migratory fat marine mammals in relation to this concept of buoyancy. It is based on a foraging theory that animals who have to hold their breath to dive for food adjust the amount of time they spend foraging in relation to the amount of energy used for ascending or descending. Those seals who are more neutrally buoyant have to use less energy to swim and can therefore spend more time foraging for food, thus showing a correlation between having large fat storages and foraging benefits. In conducting the study, 14 female northern elephant seals were tagged with animal-borne accelerometers that counted the number of flipper strokes over a large migration period. The results of the study were actually kind of interesting. All seals at the beginning of the experiment and migration were negatively buoyant, meaning they didn't have a lot of fat storage. They increased their body weight and therefore their buoyancy throughout the migration as they reached richer feeding grounds. Five of the seals became neutrally buoyant by the end of the migration period. As you can see in this graph, the strokes per metre were at their lowest when the drift rate was 0, indicating that neutrally buoyant seals use less energy when swimming. In addition, this graph also shows that when the round trip strokes per metre were at their lowest, so the more neutrally buoyant seals spent longer amounts of time at the bottom duration, indicating that the more neutrally buoyant a seal is, the more time it has to spend foraging because it hasn't wasted that energy ascending and descending. A similar study undertaken in 2013 by Sato and others also showed similar results. They also found that when body density became more neutrally buoyant, so the blue lines on these graphs, seals had smaller stroke efforts at any given speed than seals who weren't neutrally buoyant, so the red lines on the graphs, indicating that neutrally buoyant seals use less energy when swimming. Overall, this study has shown how the buoyancy of elephant seals affects the amount of time spent foraging and the amount of energy used for swimming. Neutrally buoyant seals exert less energy when swimming the same distance and depth as other seals and can therefore spend more time foraging and building up its fat storages. This in turn indicates that there is a foraging benefit of being fat in these highly migratory marine mammals, which can also have fitness and reproductive advantages.